Okay, so moving on to question 7 now. Another probability question, this time probability density function is given by this piecewise. So probability density function given by fx is k on x squared between 1 when x is between 1 and 2. Where k is a positive real number, so show k is 2. Okay, so what we do know that for a probability density function, it all adds up to 1. And so this is a continuous, not a discrete. And so again, formula sheet, continuous. For the probability density function, probability between a and b is this integral. And so in this particular case, the integral that we're interested in is the whole lot between 1 and 2 of k on x squared dx. And because that's the whole lot, it equals 1. All right, so I'm going to take this k out as a constant, and I'm going to rewrite as that x to the minus 2 dx is equal to 1. All right, and so k times integral of, not integral, we've already done the integral, so increase the power by 1, so x divided by the new power, 1 to 2, and that equals 1. And so what have we got here then? We've got negative 1 on x, 2 to 1 equals 1. So k, negative a half minus negative 1, that equals 1. So I'm going to need to go over here because I'm running out of space. So there's a plus there. So we've got negative a half plus 1. So we've got k times a half is equal to 1. So k would be equal to 2. So there we've shown that k is equal to 2. All right, so we can move on to the next part, the expectation value of x. And we're going to need to use that k equals 2 there when we work that out. So that's what they've asked us to show. So you could do, even if you didn't know how to show, you could still do this one. So expectation value of x, so ex is the mean, and for a continuous function, here it is here, it's an integral of x times the function, negative infinity to infinity, that's nominal, it's just the two end limits on your probability density function. So what I'm looking for my expectation value then is the integral from 1 to 2 of x times f of x, and that's 2 on x squared dx. So let's neaten some things up a bit. Got the x on the top, that's x over 1, and we've got x squared down here, so there's some cancelling going on. So we've got that. I'm going to put that to this one here, I'm going to put that out the front as a constant, 1 on x dx. So when we anti-differentiate, that becomes log to the base e of x, 2 and 1. All right, let's have a look. Let's go the next bit. So that means leaving that 2 out there. I'll deal with that later. log to the base e of 2 minus log to the base e of 1. All right, now key thing here, log to the base e of 1 or log of anything of 1, any base of 1 is 0. So we've got 2 log to the base e of 2 minus 0. And so that just leaves us with 2 log to the base e of 2. And then this 2 that's out the front, we can use another log law, and we can, in reverse, and we can bring it up here. It's 2 log to the base e. Oops, no it's not. I'm moving that 2 up. Let me go back. So I'm moving that 2 there, that one up to here as a power. And so I've got log to the base e of 2 squared, which of course is log to the base e of 4. All right, and so there is the expectation value of x, which is this particular random variable for that probability density function. Okay, so you need to be aware of what's on your formula sheet and what you can use from that for that particular question.